Hello students, welcome to Shankar's Physics Tutorials. Today I am going to start a new series, that is line by line NCERT series. We are going to start learning about chapter 9 of 12th Physics, Ray Optics and Optical Instruments. So chapter 8 is about electromagnetic waves, and we have learnt what are the different categories of the electromagnetic waves. So in this lesson we are going to learn about optics. So basically optics is about, we are going to learn about light and what are the phenomena that is going to be related to light. So we are going to learn one by one, and based on that concept we are going to learn about the optical instruments. Okay, so first, electromagnetic waves as a broader category, in that our eyes, human eyes, are able to detect only a small range of the electromagnetic spectrum. So basically electromagnetic spectrum consists of X-rays, gamma rays, visible light, and so many categories are there. But our human eye can detect only a small range of electromagnetic spectrum, that is nothing but the visible light, or simply I call it as light. So what is the wavelength of the light that is visible to us? That is, the visible light category is 400 to 750 nanometer. This is going to be the wavelength range our eyes can detect easily. So we are going to learn about what is the speed and how the light rays are going to propagate and what are the phenomena related to the propagation. All this we are going to learn in this chapter. So basically when we talk about light, two things will come to our mind. First one is the speed. What is the speed of the light? Can we measure it? Obviously, yes. The speed of light is going to be finite. What is the value? Just look into this value. I'm going to highlight that. So the speed of the light is 2.99792.458 into 10 raised to the power of 8. So this is going to be a large value that we are going to use it for a measurement. So to make it simple, we are going to round off the speed of light to 3 into 10 power 8 meter per second. So light can travel in any medium as well as in vacuum. So when the light is going to travel in vacuum, it is going to have the highest speed that is going to be attainable in the nature. So what does it indicates? So no other particle is going, or no other wave is going to travel with the speed which is more than that of the speed of the light, especially in vacuum. So the light is going to travel fastest in vacuum. So that one point we should know. Light can travel in vacuum with the highest speed. What happens to the other medium? The speed of the light gradually decreases. That depends upon the medium. So how it is going to be dependent, all these things we will learn about in this particular chapter. Okay, next one, how the waves are going to travel. Are they going to travel only in a straight line? This is going to be a contradictory question, right? Because in the previous lesson we have learned that light is going to be an electromagnetic wave, but here we are talking about light is going to travel in a straight line. So whether the light can travel in a straight line or it is going to travel in a wave, it is going to have both nature. That is what we are going to study in this chapter as well as in the next chapter. Okay. So for example, let us assume a light wave is going to be traveling from one point to another point. So let me choose one color. So the light is going to travel from one point to another point in a waveform like this. Okay. But if I'm going to connect the path by a straight line, this path is nothing but called as the ray of light. So you know what is the meaning of ray. So light is going to travel as a wave from one point to another point. But when I'm going to connect it by a straight line joining them, that is called as the ray of light. So I can draw a ray of light by using an arrow with the arrowhead. Okay. So what is the meaning of beam of light? A bunch of so much of rays. So like this, I'm going to have a bunch of rays or bundle of rays. It is going to constitute beam. So we should learn the basic difference between a ray and a beam of light. Okay. So in this lesson, we are going to consider the light is going to have a ray nature. That is, it is going to travel in a straight line path. So using this particular straight line propagation, we are going to learn about reflection, refraction and dispersion of the light as well. So based on this, we will learn how the images are going to be formed uh, in a mirror or else in a lens. All these things we are going to learn. So the image formation by the spherical mirrors, all these things we are going to learn in this chapter. Okay, so for that, what we need, first we should learn about what is reflection of the light. Okay, so for that we need to learn some new words, vocabularies. We will learn that now. Okay, so now we learn about reflection of light by spherical mirrors. So first we will learn about the reflection in a plane surface. We can just look into this diagram. In this diagram, we have a plane surface. This is a plane surface which is basically taken as a mirror. And what are the vocabularies you should know is the ray that is going to be incident on this plane surface is called as the incident ray. This is called as the incident ray. And the light that is going to bounce back from the reflecting surface is called as the reflected ray. And basically normal, it is going to be an imaginary surface. Usually what is the meaning of normal is, I'm going to take here, this is a flat surface, right? To this flat surface, when I draw a perpendicular that is going to make 90-degree with this surface is known as the normal. Okay, and we will learn what is the meaning of angle of incidence. So the angle of incidence here, I'm going to mark it here. The angle of incidence, let us take it as I. That is the angle between the incident ray and the normal. And what is angle of reflection is going to be R. This is going to be the angle between the reflected ray with the normal. So we have to ensure that we are going to calculate the angle of incidence and reflection with respect to the normal, but not with the surface. Please, we should have that in mind. So we should learn some basic laws of reflection as we have studied in our 10th grade itself. What is that? The angle of incidence is equal to the angle of reflection. This is going to be the first law, right? So that is why they have marked theta and theta, both the angles are equal. And this incident ray, reflected ray, and the normal at the point of incidence. Point of incidence is the point at which the normal is going to strike the surface. They all lie in a single plane. What is the meaning of plane? A plane is basically, I can draw it like this, a sheet of paper, right? So when I draw a parallel to this incident and reflected ray, it is going to form a two-dimensional plane like this. So this is about the laws of reflection. So this is valid for a flat surface. Now the question comes, is it going to be applicable for curved surface as well? So we have learned that already in our 10th grade itself in NCERT. These laws are valid for any reflecting surfaces, whether it is going to be plane or curved. So that purpose is solved. So even when the surface is going to be curved, the laws of reflection is applicable. So quickly we are going to have a quick recap about different terminologies that we have already learned. Okay, shall we see that? So what are the things we should learn? So we have learned in our earlier grades, the curved in surface is called as the concave mirror, and the bulged out surface, this front part is going to be the reflecting surface. This is called as the convex mirror. So the dashed line indicates this is the non-reflecting sides in both the case. Okay, so this diameter, this size is called as the aperture. The aperture is nothing but the size of the mirror. Okay, and we are going to learn about pole. What is pole? It is going to be lying on the surface of the mirror, which is going to be the center of the spherical mirror. That is called as the pole, which we term as P. Okay. Then when I consider a spherical surface or a circular surface like this, consider it is going to be a three-dimensional sphere. This is going to be the center. This center would be acting as what? Center of curvature for the reflecting surface of the mirror. So this reflecting surface is going to be the part of the entire mirror. So we are going to polish this only this part of the surface, and this surface acts as a reflecting surface, right? So this center of curvature for the sphere would act as what? Center of curvature of the reflecting part of the spherical mirror. This spherical mirror is going to be a part of the sphere. So we should have that in mind. Okay. So this is center of curvature, and this distance is usually called as the radius of curvature. Basically, if I consider a circle, the distance from the center to any point on the circle is nothing but the radius, right? So this radius would act as radius of curvature for the spherical part of the mirror, reflecting surface of the spherical part, right? Okay. And what is this line? The line that is going to be passing through the center of curvature, and the pole is nothing but the principal axis. These are the basic things we should know. Okay. So if it is going to be a plane surface, I can draw a normal like this that is going to make 90 degree. We have learnt this loss of reflection is even applicable for a curved surface. How can I draw a normal to it? Usually the normal to the curved surface is nothing but a line that is going to pass through the radius of curvature. So along the center to any point on the spherical surface, if I draw a line, we should consider this to be the normal. Okay, so this is going to make 90 degree. How? Suppose if I'm going, this is the point of incidence. Let us assume this is going to be the point of incidence. This is the as part of the sphere, right? If I draw a tangent to the sphere like this, usually tangent is a line that is going to pass the circle at one point, right? So when I draw a line through the radius, it is going to act as a normal to that surface, because for this small part we can consider the curved part to be a flat surface, and when I draw a tangent, the normal to the surface is nothing but along the line that is going to pass through the radius. So if I consider any line that passes through the center and it is going to touch the spherical surface, that line can be considered as a normal, right? Okay. So the same thing, whatever we have learned, how to find the angle of incidence and angle of reflection, the same concept is applied even here as well. Okay. So whatever we have seen for a concave mirror is applicable for the convex mirror as well. So the pole is going to be on the mirror itself. Center of curvature here for a concave mirror, it is going to be in front of the mirror, but for the convex mirror, it is going to be behind the mirror. Okay. So the same thing applied. So this is center of curvature and this distance is nothing but the radius of curvature. Next one, we should learn about the term known as the principal focus. So generally, what is the meaning of focus? Uh, Teachers usually recommend you to focus on your studies. That means you need to concentrate. So which is going to be concentrated here? The light rays are going to be concentrated at a particular point. So for example, let me take a different color. If the light rays are going to be incidenting on the mirror, what happens? Actually, it has to reflect back, right? So where it is going to get concentrated here, when a parallel ray like this, it is going to fall onto the mirror. After reflection, it tries to concentrate or it tries to pass through a particular point on the principal axis. So these two are the reflected rays. These reflected rays, they converge at a point known as the principal focus. So I'm going to name this principal focus as capital F. So you know very well PC is nothing but the radius of curvature and PF. So principal focus is a point, but the distance between the principal focus and the pole is nothing but the focal length of the mirror. So whether it is concave or convex, F is going to be the focal length of the spherical mirror. Okay. So basically the principal axis is the line that passes through center of curvature, principal focus as well as the pole. Okay, so whatever terms we have studied in mirror is equally applicable to lenses as well, but only difference, what is that? Instead of pole, we have a different terminology known as the optical center, which is termed as well. Other than that, everything would be the same. The phenomenon in this case of spherical mirror is going to be reflection, but in the case of lenses, we have diffraction. So while we learn about refraction, we will talk about all these parameters again. Okay. So what are the things we have learned is, we are going to talk about the light rays are going to travel in a straight line path. So it is about ray optics. And we have learned what is the meaning of reflection, the bouncing of the light rays from a flat surface, right? Next one we have seen, the loss of reflection is equally applicable for the curved surfaces as well, and we have learned angle of incidence is equal to angle of reflection, and reflected ray, incident ray, normal at the points of incidence, they all lie in the same plane. This is what we have learned. And next We have learned few vocabularies that we have already studied. So we talked about the normal, how to draw a normal to a spherical mirror, and what is the meaning of the normal through the spherical mirror, right? We have learned all about this. Next, we are going to learn about the sign conventions that we need to follow. So whatever we have learned earlier in our 10th grade, we are going to apply it here as well. Okay. So next we are going to talk about the sign conventions. So here they have given the concave mirror. So this is applicable for both the mirrors. The sign conventions that we are going to learn here is applicable for both the type of mirrors. We should have that in mind. Okay. So this is a concave mirror they have given, and this is the principal axis that is termed as the x-axis. Okay. Suppose if I'm going to, usually the object is kept always on the left. This is point number 1. Okay. When I'm going to keep the object like this, let us consider this is the object. And when the object is situated in front of the mirror, the light rays would be falling onto the mirror in this direction. From the object to the mirror, the light is going to incident on it, right? Okay. So whatever distances we are going to measure from the pole to any point against the incident light. So this is the direction of the incident light. When I'm going to measure any distances against the incident ray, that has to be taken as negative. For example, here, this is where I have kept the object. I want to measure the distance from the pole to this object. So I'm going to go in the direction in the opposite way. So usually the object distance, which we term as u, is taken as negative, because whatever distances we measure it from the center. This is for the mirror. For the lenses, it is going to be optical center. In which direction we are going? Here we have kept the object. So the light ray would fall on the mirror in this direction, but we are going against the incident light. So U is taken as negative. And what is the height? The height of the object is situated above the principal axis. So the height of the object should always be considered as positive. Okay. And where is the image going to be formed? So it depends, or depends upon the mirror. Okay, it depends upon the position, everything that is going to vary, right? If the image is going to be formed below the principal axis, the h dash is going to be the height of the image. Please have that in mind. This is going to be the height of the object. H dash is going to be height of the image, should be taken as negative. Okay. When the image is going to be formed onto this right side, okay, and it is going to be formed above the principal axis. So what is h dash? H dash is positive because the image is formed above the principal axis. And what happens to the distance? This distance is distance between the optical center, if it is going to be a lens, or if it is going to be a mirror, it is going to be pole. So distance from the pole to the image. So we are going to go in the direction of the light. So this V is taken as positive. So when we have to take V to be positive. V is positive when the image is going to be formed on the right hand side. When the image is formed on the left hand side, it has to be taken as negative. Okay, this is the basic thing we should know. So all the distances, if I'm going to measure it, it has to be from the pole or the optical center. It depends upon the lens or the mirror, right? And the height, above the principal axis, height is positive. Below the principal axis, height is taken as negative. So with this basic sign convention, what is the sign convention we have used? It is basically Cartesian sign convention. So based on this convention, we have certain rules to be followed. So that we have discussed. So the convention is Cartesian sign convention. So with this convention, we are going to derive the formula, the mirror formula as well as the lens formula, lens maker's formula for mirrors and spherical lenses. Okay. So with this, I am going to end this video. Hope you like the video. Please spread the word. Thank you for watching.